So what do we have out for homework? I don't know. Is it C and D?
Yes.
It was both of them? Okay. Is there any other questions on letter C that you want to talk about a little bit more? Yeah.
So when, like, for instance,
Number two?
when there's like, you can't tell like all the points, what do you do?
So you pick,
Just like two?
so you'll pick all of the two main points that are on there. I mean, I will have it so you can see it a little bit better. But I would say that like one of the points is 1, 2, 3, and then I'm counting off the sides. 1, 2, 3, 4. So one of them's 3, 7, and one of them's 6, 5. So if you count off the sides, you can kind of see that. But then it's not bounded on the left side. So that was a profit. So there's not a minimum profit. You're making profit no matter what. But you won't necessarily be tested on if you're making this bounded or unbounded for tomorrow. Okay. Any other questions from worksheet 3C? Going once? What?
So for the quiz, are there going to be like a lot of like the big word problems that like don't have anything given to us?
No. So the quiz is going to look like this. You're just going to have a non-calculated part. If you happen to have a 4-function calculator, add, subtract, multiply, and divide only, yes, you can use it. But it's on you to find it. So you're going to have some substitution elimination type of problem solving where they cross. Some graphing inequalities where you have to shade, this region, this, or this. And then there's one problem on the very back of the second page of the calculator part that is, you have to kind of figure out your constraints. So I would say do the best you can on that one. Don't let that one be the focus only what you study. The grid graphing stuff is the smallest percent. So do the best you can on it. Get the 4 out of 5 points or 3 out of 5 points on it, and call it good.
And then so for the like the elimination and the substitution, do you want our answers in like coordinate form or just like X equals and Y equals?
Either is fine with me. I can't remember if it says it. If I have it in coordinate form, it'll say coordinate form,
Okay.
or it'll have parenthesis, space, comma, space, parenthesis. So it'll be like that. And then there's one that we give you all the restrictions where you're looking at the shape, and you have to figure out what the ordered pairs are, and then you have to just plug in, tell me what the max is, or the min. Can't remember. It's one or the other. That's about it. I mean, honestly, I truly feel very comfortable saying that you would be able to be successful on this test, just as successful today as tomorrow. I don't, on a scale of 1 to 10, 10 being the hardest on this quiz, I would probably put it at a 5, maybe a 5.2. It's not bad. Yeah.
What have the past ones been?
Huh?
What have the past quizzes and tests been?
They've been, as far as quizzes go, I think the last quiz was a 6, and you guys scored like an 84% average between my two classes. So you guys are doing good. Y'all are doing well. You had some really good teachers' prayer. Sorry, my kids are bugging me in my pocket. All right, so let's turn in worksheet 3C. Just 3C. That's the only one I want turned in now. It's just the front and back. Make sure your name is on it. Then I want to look at 3D and go over any quick questions that you might have on 3D. We've already done quite a bit of 3D, but is there anything that we need to clarify for you? How much? 7. Is this the one you're looking at? It's like 9x minus 6y, that one? Yeah. So I'm not collecting 3D yet. All right, so if this was given to you on the graphing part, where you could use the calculator, I would say solve each for y and then graph it. So that's going to give me So you would have to try and graph that on the graphing calculator, and then this one, if you were to graph it, it's going to be y equals negative half x minus half. So this is definitely a problem I would give you the graph on the graphing calculator. And I don't have my graphing calculator up. So if you graph this, I'm not quite sure what this looks like. It looks like one's gonna, do something like this. I don't know. That's not what the graph looks like. I'm just giving an example. So on the graphing calculator, if you're gonna find this, you're gonna go through. Let's see the calculator real quick. I can't remember this stuff in my head. So you have it. It's graphed. You're looking at your graph and you see it crossing. So let's say this is your window on your calculator. So then you're going to hit second trace. So that takes you to calculate. And then number 5 for intersect. And then it's going to say first curve and second curve. So say yes and yes. And then it says, comes out with this guess. And you don't hit guess, you just hit enter one more time. So this is enter, 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 and then it's going to show you the intersection of the two. If your window does not show the two intersecting on that, and you know they intersect, like let's say your window looks like this, and you have one graph that's doing this, and another graph that you see it's doing that, and it's not happening off the graph, the intersect command won't work, so zoom out, enter, as many times as you need so you can see it intersect. And then remember, zoom standard will take you back to the negative 10, positive 10 every time. Does that make sense? And I don't have the answer to it, but I would definitely do this one on the graphing calculator. Those are nasty equations to graph by hand. It doesn't mean that they might graph or might cross at like 5, 6, and you're like, how did that something so nasty graph? Well, it could happen. So if you graph that on your graphing calculator and you come up with an answer like 5 and 6 for your x and your y, don't think that you're wrong. Just think, oh, that's just one of those dorky problems that happens across that's ugly to graph. Any other questions on the D? Yeah.
Number 9.
9. Same exact idea on number 9. This one's already set up for you. If you're using the graphing calculator, I would definitely make sure I plug that in. And then the other equation, it's not set up to graph. Cover method's not going to work, so this is definitely one I would have on the graphing calculator part. So solve the second equation for y. Make sure that's in parentheses. That's a 1/3, I'm sorry. And then that's a minus 20 over 3. And I'd also make sure that was in parentheses. When you graph the two, again, it's the exact same procedure. You know they will definitely cross each other because negative 3/4 slope, 1/3 slope, two different slopes, they definitely will cross. Okay, it's just a matter of using the calculator.
Okay.
Cool. And then like always, if you're sitting there getting like error on your calculator, call me over. Let's take a look at it, because it's very possible that you have done every setup correct, but your window can't see where it's crossing, so you're trying to do the intersect and it's saying error, and it might say something, no sign shift or things like that. Just don't let that bog you down, because I'm testing, yes, if you can use the calculator, but it sucks when you're sitting there at the calculator and you're stuck in an error that you can't make better. And sometimes it means you just put the subtraction key in rather than the negative key. So it's kind of goofy. We good? You feel all right? So I have 3C turned in. Why don't you turn 3D in tomorrow? I think you all have a pretty good. I strongly feel in my heart that there's not going to be any difference between whether you took it today or tomorrow. I know the anxiety of today might have been a little bit worse, though we might have had a boy cry. I don't know. Yeah. Number 11 on 3D. Okay, let's take a look. Okay, stored. Okay, this is a great problem. You will definitely see one similar to this. This is not like we're graphing restraints or anything. We're just getting two linear equations, and we're going to solve where they cross. Is what we're doing. So you have AA batteries. We'll call those X, and then you have AAA batteries. We'll call Y. It doesn't say anything different than that, would it? So it tells you that a package of the AA is 279. We'll call that X, okay? And the AAA is 249. So we're going to call that Y. And we just spent $20.82 on buying those batteries. And then the other one says, well, I happen to buy 8 packages of batteries at that point. Okay? The only thing I would probably change on this is I'd multiply this whole thing by 100. And so that would give me 279x plus 249y equals 2082. Oh, there's no decimal there. Forget that. It's just 2082. And then you have to pick one of the equations to get rid of. So I would, between these two equations, I'd probably use the addition method. Maybe multiply this whole thing by 249. So here, here, and here. When you add them together, the x values, or the y values will fall out. And then you solve for your AA. And then once you solve for AA, this will come out to like 6 or 2 or some combination. That'll get up to 8. Okay? And if you got stuck on that problem, here's the nice thing. You spent $20.82. Agreed? So you know that's your go-to. You only have 8 packages. So you'd be like, okay, if I have 1 of these and 7 of these, no. If I have 2 of these and 6 of these, no. If I have 3 of these and 5 of those, and you're just trying to get to 2082, if you get stuck on it. Okay? I wouldn't, that's not the strong go-to, but at least you're using some problem-solving skills in order to get there. Now, if I was looking for, 850 packs of batteries, that's really going to suck. Going, okay, I have 849 packs and 1. Nope, 800. That's going to be horrible. Does that make sense? Are we good? Can we go to the notes?
Yep.
All right, so we will have worksheet D. Was it 3D? We'll make that due tomorrow. So you can look at that. And let me get to the front of my notes. So this is, I think you'll feel pretty comfortable with the notes. You've seen a lot of this information throughout days. I know that on your notes you're not going to have everything, so I'll give you the opportunity to write down. Please tell me if there's something I have on the board that's not on your sheet. So we're talking about functions, domains, and ranges. Okay? Domain goes with X, range goes with Y. Domain and range go hand in hand with each other. How I tell kids to remember domain and range. Domain and range. Domain starts with D, range starts with R. They're alphabetical. Agree? X and Y are also alphabetical. So you know the domain goes with X, the range goes with Y because they're both alphabetical. I know it's a silly little trick to remember it, but it helps me a lot of times. And I know when I was in high school, I discovered that and I thought it was genius. I was like, dude, why don't they just teach this? So if it helped a dum-dum like me, it's going to help you guys because you're not dum-dums, you're smart. Okay, so understanding functions, apply domain and range to functions, and then evaluate functions is what we're going through. Is everything on here other than what I just wrote in green on your thing, on your page? And then a function is just a special type of relation. Okay, so this might not be on your page. So a relation is a matching or pairing of input values with output. Now, I want to show you one more thing. Input, oops, I didn't mean to do that, sorry. Input starts with an I, output starts with an O. That's also alphabetical. So input goes with domain, input goes with X, output goes with Y, output goes with the range. It's alphabetical as well. And again, I thought this was the greatest thing in the world. Though finally in math, somebody actually put something in order I could remember it. So if I say input, output, it's a fancy way of saying X and Y. If someone said domain and range, again, it's a fancy way of saying input, output, or domain and range, or X and Y. They all go hand in hand with each other. The domain is a set of input. So this means it's this X values for a relation. A relation is just a fancy way of saying, hey, we got a bunch of ordered pairs. We got points. And now we're going to show you how we would write those points. Does anybody need more time writing down this page? You good? Have you ever heard about domain and range being that way?
Yeah.
That is alphabetical? Sweet, I'm the first. Yeah, I taught something. Finally taught something for the first time in my life. All right, so a range is the set of output values for a relation. Output goes with what? X or Y? Y, it's alphabetical. So a set of Y values. And then a function is a relation with exactly one output for each input. So it's one Y for each X. And we'll talk more about what this means. So a function is just a special relation that a certain categorical event takes place of our points. Okay? Ways to represent relations as functions. We can look at the mapping. Okay? Mapping is just, I don't know. I gotta be honest, I've never seen out in any type of schematic drawings or anything like that, mapping diagrams. I've seen points added where it's done. Obviously, equations exist, graphs, tables. You will see tables a lot of times in science, but the mapping diagrams, I don't know where they exist in life. So why do we teach it? Well, they say we have to because some really smart math person who has never taught in a classroom said this is important. I'm not that important math dude. Could I move on? Is there a or uh-huh? You good? Aren't you glad we're not taking a quiz right now?
Yeah.
Thank you.
Just gave us one more day to worry about it.
Right.
Do you think the people who aren't here feel pretty funny that they're missing my lesson?
We're coming tomorrow and be like,
The quiz is gonna be on their desk and they're gonna freak out.
You know what I'm gonna do? You guys get the easy version. I'm gonna make one that's like pre-calc with integral signs.
you should definitely do that.
The directions are like in Japanese, while the problems are written in German.
Cooper can't even spell his name, I don't think.
It happens. It happens. But they showed us, so like screw that. I'm gonna ask.
Screw that
I'm gonna ask all my friends how it was, and all of a sudden they're gonna talk to y'all if you're friends with them.
Hardest quiz ever. Someone cried.
Boy.
Boy cried.
And they're like, what boy? It's like, I
The
don't
one
know,
that sits in the back.
some
The one
dude that sits on the other side of the class. I don't remember his name.
That one kid peed his pants.
Kyle.
All right. So ways to determine if a relation is a function. You consider the domain and you check the range. For the graphs, use the vertical line test. This is the easiest of them. Looking at a vertical line test. If you have a picture drawn, and you can draw a vertical line through anything, so straight up and down line, if it goes through and it touches your picture twice, that is not a function, which is just saying, hey, look, everything matches up. And then for quadratics, consider if it's linear or quadratic. So for equations, consider if it's linear or quadratic. So if it's x squared versus x. Okay? But the vertical line test is the easiest thing to do. Kids always want, hey, just have me have a whole page of pictures I look at, and I draw a vertical line, and I can tell you if it's a function or not. All right. This is one of the mapping things. And again, I've only seen this in math class. I've never seen it in any real-world applications. So ready for the domain? So we take a look here. We took there. So my domain in numerical order, but it's not the most important thing if you don't put it in numerical order, is this. There's my domain. These are my x values. So usually on the domain, yes. On the range, these are your y values. So your range, again, in numerical order. Is that. Okay? Now, don't confused that you wrote the domain in numerical order, that -5 goes with -8. I'm sorry, I didn't get that. So don't confuse this. You realize that the point 2 comma -8, -3 comma -2, -5 comma 7, 4 comma 8, 0 comma 0. Those would give you just the points. The domain, so -5 you know does not go with 8. So you can't necessarily take the domain and go backwards if you've written these in numerical order. If you write it in the order of the map, it's probably fine. Then you would probably have to determine that 2 goes with -8. So just be leery on how they would go. Again, the domain is also known as the input, and the range is known as the output. Okay? Again, they're all alphabetical, which I think is pretty helpful. Am I doing okay so far?
Yeah.
Moving on. Okay, the domain here, well, let's just do the range. What's the range? 7. Is everyone okay that the domain is this?
Yeah.
And they all go with 7, which is great. So the domain are my what values? Which is also called the range is the, which is called the, and X and Y, input, output, domain, and range are all alphabetical. Cool? Can I move on?
Yeah.
All right. So the domain, I can go ahead and list it in order. And then take a look at the range. 2 goes to 7. And it goes to -8. Now I'm going to change the order of these. 5 also goes to 7. 5 goes to -2. 4 goes to 8. And 0 goes to 0. Now I didn't put these in numerical order, but do you notice that the 7s happen twice? Okay? So the domain is your X. The range is your Y. The domain is called your input. The domain is called your output. And then something's going to happen because I have this and this. It's still a relation. We still have points. It could still be a picture we're looking at. But it might not be linear. It might not be quadratic. It won't be a function. But we'll find that out in a moment. Can I move on? If I move on too quickly and someone didn't see it. The domain, X values. The range, Y values. The domain, X values. The range, Y values. Each of these makes points. So I have the point -5, 8, -8, -4, -6, -1, 0, 0, 2. Those are all points. And that's really all you need to know about the domain and range. Of course, I didn't realize there was a second domain and range because I didn't see it on my page. But I think you get the gist of it. We good? Pretty simple?
Yep.
Told you the notes are kind of quick. All right, so the domain. Best thing when you get these types of problems is go ahead and list the points. So I know that's 3, 1, that's 2, 4, that's 1, 3, that's -1, 1, and that one's -2, 3. The domain, well, let's just pick some order. Go left to right. -2, -1, 1, 2, and 3. That's my domain. My range, go from bottom to top. 1, 1. Let's see what else. 3, 3, 4. What do you think? Would my vertical line test work? I draw a vertical line test. Do I touch 2 points by any one particular vertical line? No. So this is probably going to be a function. Okay. Make sense so far?
Yes.
So usually when you're listing domain with points, list from left to right for the X values. When you're doing the range, list from bottom to top. Okay. Is it totally wrong if you don't? No. All right. The domain of my red line. Does that red line appear that it'll go forever to -infinity going left and to forever going to positive infinity to the right. So my domain goes from negative to positive infinity. My range, will it go forever keep growing to the left and decreasing to the right on my red? So my range is also negative to positive infinity. You read that left to right. Letter B, will it go forever left to right? So negative to positive infinity. Okay, what's going on with my range? Yeah, it's just 5. It doesn't do anything else. That's the only y value you get. Your only output is going to be 5. Okay, let's see what else we can do here. All right, letter C. That black line. It's going to go forever left, right? Is it going to go forever up, down? And then letter D, negative 6 is our domain. And it's going forever from negative infinity to positive infinity. And this is the one that is not a function. Because if I draw a vertical line, it'll cover it an infinite amount of times. If you draw a vertical line to the right of it or the left of it, it'll never intersect it. If there's one vertical line that matches up identical to it.
I guess you defuncted it. Function?
Oh, jeez.
Unnecessary.
I'm sorry.
All right, can I move on? Any questions so far? All right. Letter B, it's the red one. I'm just going to do this. I'd like you to put it there too. I'm going to put an arrow on that end. Okay, we didn't have arrows. Is this going to continue to grow that way and up,
Yes.
and this way and up?
Yes.
So the red goes from negative infinity to positive infinity. My range, well, this is called a parabola. So my range starts down here. It's a little bit less than 0. Like, let's just say negative 0.1 because it's below it. Negative 0.1. And it's going to infinity because it's growing upward. Is letter C a function?
No.
Go ahead and put an arrow on both sides. It's not a function, but it doesn't mean you can still listen to the domain and range. The domain appears that it is starting at like negative 0.5 and going to infinity. The range, this is going to continue to grow upward. This is going to continue to grow downward at a slow rate, but it's still going to do it. So our range still goes negative to positive infinity. Because I could draw a vertical line through it, this is not a function. And then letter M, it's kind of a bound oval. So my domain appears to go from like negative 3.5 to 1.2-ish. And I'm just guesstimating. And then my range going from the bottom goes from about negative 6 to about 3. It's a closed object, so is it a function? No, the vertical line test definitely would not work on that one. Feeling comfortable? Am I going too quickly for anybody? Did some boy start crying? Can I move on? We got 10 minutes, right? Yep. All right. Okay, now, determine if it's a function is odd, even, or neither. Okay. Is the function a one-to-one function? All right. If it is, so it says letter A is even, but it's not one-to-one. Okay? Even functions means this. If you graph it, it'll reflect over the y-axis. So if I graph this, the y-axis acts as a mirror and fold over right on top of itself. That means it's even. Okay? One-to-one means for every x, I have exactly one y. Okay? But and for every y value, so I have 2. Come on, give me a point. 3 comma 5, and I have negative 3 comma 5. Being I've used my range twice, it's not 1 to 1. 1 to 1 means for every x there's a y, for every y there's an x. It goes backwards and forwards. Okay? So an even function can be folded over the y-axis. The reason why b does not work is because I can't fold b, which is the lower black one, I can't fold that over the y-axis. It's not symmetric about it. If I fold this over the y-axis, I get another whole duplicated thing over here. It won't work. And then, and it's not 1 to 1. And it's not 1 to 1 because you have a repeat in the y values. Yeah.
What does a 1 to 1 function look like?
Best thing would be a straight line.
Okay.
Okay. Or just dots.
So
Dots of
most-
points.
So most likely these
So a parabola will not. A parabola will be an
Will
even
there
function if it's symmetric about the y-axis.
But will never be a 1 to 1.
It won't be a 1 to 1. Right. And then letter C. It's not a function at all because the vertical line test doesn't graph. And then if you reflect it across the y-axis, this would be facing this way now. So that's not going to work. Okay? So algebraically, function at x and function at negative x, that's going to give us the even functions, which means if I plug negative 3 in, I get, if I plug negative 3 in versus positive 3 or any number, I get the exact same number out. So there's your even. Okay, 1 to 1, every x value is uniquely paired with a y value, and every y value is uniquely paired with an x value, and I think I had said that. And it passes both the vertical and the horizontal line test. The vertical line test we already talked, 1 to 1, horizontal line test also works. Horizontal line test does not dictate if it's a function or not, it just dictates if that function is 1 to 1. Okay? Was that on your paper, the 1 to 1? Okay. Started looking because things didn't get there. All right, so letter D. Letter D, is it a function?
No. Yes.
Vertical line test works on the green. If it's a function, is it symmetric about the y-axis? I think this green line should continue forever. So it is a function. It is even or odd? Even said what? It's even because it's, whoops, I went the wrong way. Symmetric about the y-axis. So even. Graph reflected across the y-axis is the same as the original graph. So if I flip this over, if I flip that over, it does that. So it's even. Does it pass the horizontal line test to say it's 1 to 1?
No.
If I draw a horizontal line, can I touch it twice?
Yeah.
It's not 1 to 1 then. Okay? Letter E. Is it a function? The purple?
Yes.
It is a function. Is it even?
No.
Is it odd?
No.
It's neither. Okay? And I'm going to show you an odd here in a second. Letter F. Is it a function?
No.
Vertical line test? No. And it's not 1 to 1 either, so it's not exclusive. I would say, I'm not going to worry about that. Letter G. So letter G, this is the equation basically y equals x to the third power. It does this. It has a wiggle through the origin. So that is the definite. It is a function, and it is odd. Okay. So, huh?
How would it be?
Because if I draw the vertical line test, this is continuing to grow out this way, and this is continuing to grow this way, very slightly, but you won't have any repeats. And the reason this is an odd function, there's a couple ways to think about it. Could I put my finger on the origin, and could I rotate it around the origin, and it comes back onto itself if it passes through. Okay, so that works. The other way to think about it is this. Okay, if I reflect this over to here, so I reflect it over the y-axis, and then I reflect it over the x-axis, will it map onto itself? So if I reflect this, so let me draw it like this. So if I reflect this part here, and it reflects to here, and then I take that part here, does it reflect to here? That's what's going on with it. And I'll take that away because we don't need to look at those. Okay? So odd functions are symmetric about the origin, so it's symmetric about the point 0, 0. Even functions are symmetric about the y-axis. And this one would be 1 to 1 because it's going to pass the horizontal line test. Am I close? I got 4 minutes, 3 minutes. All right. So this is called functional notation. You want to know what it really is? Y equals. Well, we make it called functional notation. It's like, oh. So I've heard this said a couple ways. So this is saying the function at x. I've also heard people say the function of x. What's the correct way? Don't know. Doesn't really matter. Functional notation means you're making y, not say y equals, it's now saying the function at x or the function of x, f at x. Okay? What forms of the equation would linear functions have? Well, a linear function would be like this. And are all lines function? No. Vertical don't work. Okay? Vertical lines are not functions. All right. See that -2? I'm going to make this. That gives me this. Which gives me this. See that -2? Plug it in here. Plug it in here. And I'm going to do the math. So that's 4 plus 8 plus 3. 11, 15. Now here's where it gets a little trickier. See this? That gets plugged in entirely here. Did you see what I did? There had been an x here. I replaced it, the whole thing with x minus 4. I still have the -3, I have the -5, and the -2 up front. And then same thing with this one. So again, I just replaced my x with x minus 4. Am I done?
No.
Oh. What am I going to plug in? Third root of 8x to the third plus 2. And this one's going to be -3 over 8x to the third minus 2. And reduce that to -3, x to the third minus 2. Is that it? Yay or nay?
Yeah.
That's it? All right, so let's do tomorrow.
4A.
So 3D is due tomorrow. 4A is due.
Tomorrow.
Tomorrow is Wednesday, right?
Yeah.
So this will be due on Thursday. So this is 3D is due tomorrow. Quiz tomorrow. 4A, and you know what? Tell those dudes that we took the quiz.
We will.
Okay? And then 4A is due on Thursday. Have a great day. Take care of one another.